Alright, so this video for biochem is over hemiacetal and acetal formations. So these are our last aldehyde reactions. We're also going to do the same thing for ketones. I hadn't made these notes previously because this is actually kind of a hard reaction to explain. So I'm going to go through a few examples for you, make sure that you're following along. But we will try to do a lot of practice with this. I don't know if there's going to need to be some give and take in a meet or something like that, but you will figure out how this one works eventually. It's just a little strange at first. So again, this is an aldehyde reaction, so I'd have to have an aldehyde to start, but a hemiacetal forms. We're going to focus on this hemiacetal first. So on this slide, it's the hemiacetal. Next slide, it'll be acetal. A hemiacetal can react with an alcohol of some kind. So let's say I have this ethanal, Al ending, right? And then I have a isopropyl alcohol, right? So when I react these two things, again, I always have that carbonyl group for a aldehyde. So let's just draw that down below here so we can visualize it for a second. You don't need to do this in your notes necessarily. Just make sure you're understanding. And I have this hydroxyl group, that OH, for an alcohol. Again, the alcohol has something hanging off of it. There's this isopropyl group, that R group, right? Whereas the aldehyde in this case has one more carbon, a methyl group hanging off of it, right? But I'm reacting these two groups together. I'm reacting this carbonyl group, the carbon double bond to oxygen, and this OH in that hydroxyl group for my alcohol. And all I'm going to do is I'm going to take electrons, and it's kind of like what we were talking about before for other types of reactions, so it should be actually somewhat familiar, right? I'm going to break some bonds here, and I'm going to remake new ones. So it kind of looks like an addition reaction that we did before. I'm going to take these electrons from this carbonyl group, and I'm going to make a new bond between this oxygen and this hydrogen. I'm going to take the electrons from the hydroxyl group, and I'm going to make a new bond between this carbon and this oxygen. So what ends up happening is I've made a product that's going to look kind of like this, right? So I have the oxygen, and then I have a hydrogen attached to that oxygen in my carbonyl group. And then I'm going to have, again, I'm kind of switching colors here so it can be a little bit more obvious for you, this kind of thing going on down here. Now, normally I wouldn't draw that way, right? If I'm doing this up here when I'm reacting these two original things, I'm just going to take my carbonyl carbon, I'm going to redraw my aldehyde without that bond, and it's actually just going to be a hydroxyl group now. And then I'm going to connect to an oxygen that's going to be connected to an isopropyl, since that was an isopropyl alcohol to begin with. But I kind of want to see where those atoms came from and how I shuffled this to make that product. And it's a little easier if you look down below and see what I did there. So again, I'm only going to do what's in black on a test, on a quiz, but this is what this reaction looks like. And this final product that I made over here is what we call a hemiacetal. When you see this oxygen, carbon, oxygen in this look, when you see that hydroxyl group and you have a carbon, oxygen, carbon next to it, that means that it's a hemiacetal, right? It was formed from an aldehyde and an alcohol. So this is an important reaction later. We're going to talk about it when we talk about carbohydrates, when we talk about sugars like glucose later on. But otherwise, the reaction itself is a little funky. It's a little weird to follow along with, but just make sure you understand the process. Right, so that's my hemiacetal formation. Right? We'll do lots of examples, but make sure you have at least one in your notes, and then we'll go from there. Whereas I also have acetals that I'm going to be worried about. And acetals a little bit different. So it doesn't really matter what color here, but my acetal formation, I'm going to have a hemiacetal already built. So let's say I have that hemiacetal from the last slide. that looked a little bit like this. And I'm going to react that with another alcohol, right? Not really, doesn't really matter what that alcohol is, but let's make it a propanol in this case. So it's a little bit different. We can see the difference between all these different R groups. Okay, so this reaction is a little bit different again. So I'm going to focus on some individual parts. I'm going to focus on this hydroxyl group here. Again, that's an oxygen and a hydrogen that are bound together. And then I'm going to focus on this hydroxyl group over here, right? Same idea. And I have at least one carbon attached there. Obviously, it's more than one carbon. There's 3 carbons there, right? And there's a lot more stuff going on down here, but we don't need to focus on that right now. So what I want to see here, and this is the simpler version actually. This one's, well, I don't know if it's simpler or not. And it doesn't really matter which side you think of it coming from, but essentially I'm going to take, to make my acetal, I'm going to take one complete hydroxyl group and a hydrogen, and I'm going to turn those into a stable byproduct that you guys should be familiar with. 2 hydrogens and an oxygen, that's a water, right? And then from there, all I have to focus on is I have to make sure that my oxygen, that pink oxygen here, right, is still going to be connected to something. I'm going to connect it to this blue carbon down here, right? So I need to make a connection between those 2 atoms, right? Because in between those 2 atoms was the water that was removed. Again, I could kind of draw this differently and orient it differently so it looks a little bit more obvious what I'm doing. Maybe I should do that. Let's flip that around a little bit. If it was a carbon with that hydroxyl group like this, actually, and then I had my hydroxyl group in the pink portion of this like that, right? Now I can see it a little bit better. When I remove the water, I'm going to take electrons from one of these bonds to make a new bond here to make a water. But I'm going to take these electrons and I'm going to make a connection here between that carbon and that oxygen. And again, this is just visualization. You don't have to draw that every time. It's just so that you can kind of see what's happening, right? But when I combine these 2 reactants above, and again, you need a catalyst, this hydrogen ion catalyst, all I need to do is redraw everything kind of similar to what it looked like before. So you can see how this part of my hemiacetal is still there. And then I'm going to draw a connection to an oxygen, but this oxygen again, it doesn't actually matter which oxygen you think it is that oxygen that's connected to 3 more carbons, because that's my alcohol over here. And this product that I made is an acetal. So it's kind of hard to draw these reactions and come up with these products, and they're really hard to recognize at first. But this is an acetal that I created here, and we don't know how to name these things. You just have to tell me it's an acetal if you wanted that bonus point. Whereas on the last slide, my product was a hemiacetal again, right? I don't usually write the whole thing out. I usually just write hemi. So that's a hemiacetal. But hemiacetals can react it with another alcohol to make acetals. So I'm building this acetal one step at a time. And you just have to get used to doing that. So again, kind of a strange reaction. I could show you one more quick intro to that. Again, I could have any aldehyde. So maybe it's a butanal to start, and I'm going to react that with a methanol. Remember, a methanol, 1 carbon and a hydroxyl group, right? If these 2 things are going to react together to make a hemiacetal, again, I'm just kind of shuffling the atoms around. I'm going to redraw my aldehyde with 1 bond to that oxygen, and instead of that being a double bond to oxygen, it becomes a hydroxyl group. And then from the original carbonyl carbon, which is this carbon right here. I'm going to say that a lot in the future, so make sure you know a carbonyl carbon was the original carbon that was double bonded to an oxygen. But that carbonyl carbon is now going to be attached to the oxygen in my alcohol over here. And then I just have to make sure I have the right number of carbons attached to that alcohol. So my aldehyde, a butanol in this case, plus a methanol makes a hemiacetal that looks like this. And then I could react it one more time with another alcohol. Again, just draw that hemiacetal. And you should learn to recognize hemiacetals and acetals at some point. And I can react this with another alcohol. So I can make this alcohol be cyclic if I want to. It doesn't really matter what it looks like. So I got a ring with a hydroxyl group. So it's a cyclopentanol. And before and after, again, should put my catalyst in here. Sorry if I'm forgetting that. All I have to do is attach everything together. This part all looks the same essentially, but then this oxygen is now the oxygen that's in my alcohol, but that should still be connected to a ring of carbons, that's cyclopentane, right? And I removed water this time. I do not remove water in my hemiacetal reaction, but I do in my acetal reaction. So that's a major difference. Make sure you understand what's happening in each. But I can take an aldehyde from the beginning and I can turn it into this acetal at the end by adding a couple alcohols to it. So again, kind of a weird looking reaction. One of the things that I'll actually do in the future is I will start you out with a acetal, hemiacetal, and make you work backwards. So I could draw something that looks like this, and it's going to be kind of goofy looking at first. And you need to be able to break this up into its parts. This is actually an acetal. And I know it's an acetal because I can see all the way from one end to the other. I don't know what color I was using before, but I can see that there's a carbon here that's connected to two different oxygens. That carbon is going to be my carbonyl carbon in my aldehyde, right? And I can see that those oxygens both have other R groups that are hanging off of them. So if I give you this acetal and I ask you to break it down, because these reactions are reversible, I should actually have a double arrow on all of these things, because I can break down an acetal back into its original components. Right? These should technically all have double arrows on them. They're all reversible. So if I'm going to break this down, the main thing I focus on is my carbonyl carbon. That pink is part of my aldehyde. So that carbonyl carbon had two other carbons hanging off of it. So there's 1, 2, 3 carbons total. That's going to be my aldehyde. Off the end should be a double bond to oxygen. And then I'm going to have 2 alcohols, right? And those alcohols should be pretty easy to recognize at this point. There's an isopropyl alcohol, right, for the top one here. That was alcohol 1. Alcohol 2 looks like it's a 1,2 ethanol. So those are the pieces that I'm going to take out. Now, it kind of depends. You can do this all in one, or you can do it in a multi-step process, right? I might ask you to do it in a multi-step process. First, you're really just going to remove one of those alcohols. So you might start out by saying, okay, I'm going to take out the isopropyl alcohol, and I'm just going to leave behind a hemiacetal. Again, that hemiacetal still has my 1, 2, 3 carbons, including my carbonyl carbon. Again, I'm kind of drawing this from scratch, so it looks kind of weird. But then I'm still also going to have this oxygen and these 2 carbons, whereas up here I now have a hydroxyl group because all I took out was my isopropyl alcohol to begin with. So I could break this up into parts and have a hemiacetal here. And actually, which alcohol you remove is dependent on which one you will feel like removing, because it doesn't really matter which one you remove first. So this is the isopropyl alcohol and a hemiacetal, and then I can remove my final alcohol. Again, there's an ethanol here that can be removed, and I can get these same products that I had up here. I just have already removed my isopropyl alcohol, but then finally I'd break up that hemiacetal into its two parts. So again, I have 3 carbons, I have an aldehyde, right, including my carbonyl carbon. Whereas the rest of that needs to be removed would be my other alcohol, my ethanol, right? So sometimes it's easier to visualize this one step at a time. Sometimes you just want to do it all at once. But again, I removed this alcohol first. That doesn't mean I couldn't have removed the ethanol first. I removed this alcohol first to make my hemiacetal. Then I removed the ethanol to make my aldehyde. So should understand that I can do this in either direction. I can make you build an acetal from scratch, or I can help have you break down an acetal. But also know how that hemiacetal breaks down, because what if I just started you with that and had you break it down instead? So you should have a couple good examples in your notes.